Hello everyone. So um, yeah, hello everyone again. I am glad to see you. Today I'm gonna, as discussed last time, I'm gonna continue the series about mesh modeling techniques, and because many of you have requested us on Instagram and on other social media. Yeah, we will be talking about how to make a complicated mesh texture or mesh three-dimensional form from really simple mathematical equations, graphs, and like curves and so on. So yeah, let's start. I mean, the preview image kind of explains what is the end goal of our today's exercise, and I think it will be quite short this time. I would also like to remind you that me and my colleagues, we have created a parametric design market. So if you would like to purchase any scripts from there, or if you'd like to support our team, we will be glad if you buy something there. The link will be in the description. And if you'd like to arrange some individual or group classes, please also DM us. We'll be always glad to work with you. So let's start. What are we going to do? Let me make, I'm going to bring in the bifocals, and first of all, I'm going to name some of the plugins that we will need today. So definitely it will be the plugin called Peroptera. It will be the plugin called Weaverbird, and it will be a plugin called Pufferfish. I think that's it for now. If there is anything else to job in the script, I will mention the name of the tool. So what are we gonna do? We're gonna make let's say somehow complicated. Well, not complicated, but like fancy mesh structure from really simple mesh surface. But instead of using the base mesh, we're going to be using some base curves, and using its data structure, we'll be developing a shape that can be easily manipulated and easily turned into something let's say attractive or and also controlled. So let's start with making a really simple. First of all, I'm gonna bring that plane. Let's start from making a really simple curve. Like we go for construct point. We make a line SDL like this. So yeah, along the x-axis. I'm gonna make it go both ways. Actually, you know what? Let me show you another method to do it. So maybe instead of using that SDL, we're just gonna move this point and turn it into a polyline. So if we want to move it in both directions, we just take this vector and this negative uh, side. So it's gonna be the reverse vector, and then we let's make it something around maybe 80. So yeah, as you can see, these 2 points are moved in both directions, and then we just turn it into a polyline. So it becomes a straight line, in fact, between two points. But yeah, we still use the component of polyline. It's a bit counterintuitive, but yeah, it is what it is. Now we're going to disable the grid so it doesn't confuse us. Yeah, let's move on. Let's start with dividing this polyline into multiple into multiple segments, and this is basically how we define the resolution of our mesh. Actually, first of all, let's create multiple polylines. So let's move this along the z-axis. Let's move it using range component. We can also do series, but I think in this case it makes a bit more sense to use range, because if we are if we are going to develop a certain shape or a certain wall, column, whatever, we will be aware of the total height, so it kind of makes sense to use range. Let's say the total height will be around 600. Again, these dimensions don't mean anything. It's just about yeah, just about making it look nice, and then of course you can make these dimensions as high as you want. I'm gonna also divide it into, say, a unit of maybe 5 for now. Maybe it's a bit too much, too small, but it's okay. And of course, we're going to use the z vector. So these are the numbers and the amplitudes, if you want, and this is the vector. So we're going to move it along the z-axis, vertically up. This seems about fine to me. Maybe make it a bit lower. Let's say 540, maybe something like this. Yeah, should be enough. Okay, let's move on. Now I would like to divide these curves into certain amount of points or segments. Let's say we're also going to use the length of these curves, and the length is actually this, so they all have the same length. So let's take this the length of this polyline, and let's divide it into I don't know, let's say. Let's try to start with the same dimension so that we are getting a square mesh in the end. Seems about fine to me. So now let's. There are two ways. We can either shatter these polylines, and we can just make new polylines from these points, and then just explode them. So it's up to you guys to decide. So let's say explode, and yeah, this is it. And we will be interested mostly in points here. Sorry, in segments. So yeah, so we're taking the curves. This is seems to be just fine to me. Um, okay, great. So now, basically, this is like each of these not lines, but each of these rows of segments is a separate branch, right? So and if we want to build our base mesh, we will be mostly interested in this vertical segment. So we'll have to flip last. So if we want to just build a really base mesh, we go for flip last. Take it like this, and this is a component from Heteroptera. Sorry, it's not from Heteroptera. It's from I think it's from three slope, if I'm not mistaken. Three slope, yeah, I think so. I will add the link with all the plugins into the description of this session, so you'll be able to find it. If not, just check Fit for Rhino, and you'll find it there. So after that, we need to create pairs from these lines. So basically, like the line from here and the line from here, they should form one ruled surface. So let's just take it like this. We also need to invert the wrap so that it stops at some point, and the last segment doesn't make a pair with the first one, right? So, and then for the other one, we sorry, no, for the other one we say we have the expression say minus x. Right. So okay. So now we just say ruled surface. And as you can see, we have 108 segments in each branches here, and 108 segments in each branch here. So as a result, you see, we are getting a really clean and really clean quad mesh. It's not a mesh yet; it's just like NURBS, but with a simple mesh component, which I think comes from Mesh Edit plugin, Mesh Edit or Mesh Tools, I don't remember. But you will need probably both of them, so download them in any case. if you like to work with meshes. Yeah, and then we just need to weld it, and that's it. This is gonna be our mesh. But our idea is not to make this base mesh and turn it into a more complex one later. Although this also can be a way. Our idea is to manipulate these curves and get the complexity from there. So, what are we gonna do? Well, let's try to do it this way. So we have these all these segments, but we also have all these vertices, right? All these vertices, and each vertex is basically a point that can be moved, right, following a certain vector. So how are we going to find the direction? Well, right now it's quite easy because if we use the x-axis to create this line, it means if we're using the y direction, we can get this motion perpendicularly to the curves. But the thing is, um, we're not sure if it's gonna be um, because we might also work with a more complex surface, and this technique will work with any surface, right, or any direction. So what I would suggest us to do is we can say first of all sheet of paths, right? This is definitely a two-slots plugin. So we take these polylines, we turn them into one list, and then we make a loft from it, right? So as you can see, it's an untrimmed surface, so it's exactly what we need. And then we just need to move these points following the normal to the surface. So we are taking a component called surface closest point. This is one component we will need. And then we need to say evaluate surface to get the normals, right? So something like this. And of course, yeah, we need to, I mean, we don't need to reparameterize in this case, but just to, don't really need it, but I'll still do it. So we take the surface, we say parameterize, and that's it. Okay, so now we have the normals, right? For each point, we have a corresponding normal. And also, what is even more important, we have our data structure, and it's here. So we're going to move our points using the component called amplitude, and the vector will come from this normal, right? But then we are interested in the amplitude, and this is interesting because how are we going to get this amplitude? This is completely up to you to decide how do you want this amplitude to be, like how do you want it to be generated, right? So I would say I want my mesh to be going from to be changing from bottom to top. I want stronger relief in the bottom, and I want it almost flat on the top. But I want not only this, I also want the total shape to be not completely flat, but to be more like semi-column, let's say. So how can we achieve this? Well, first of all, we need to first of all, we take the tree statistics because clearly we're going to be operating with data trees, right? Because all these points um, they form a data tree, right? So we have 109 branches. We also have each branch is 33 points long, and these are the paths, right? The paths we won't be interested in them this time, but we will be interested in the count and in the length. So yeah, let's say that we want our curves to be affected by their order, and as this curve is first branch, second branch, and so on. This is the last branch, so we're kind of sorted here. So first of all, I want to create this very default, very basic combination, which is formed by graph mapper, remap numbers, um, bounds, and constructor name. Now I would like to ask everyone who follows me to pay attention, because we will need to make two graph mappers. First graph mapper will control the change of amplitude inside one branch, and second graph mapper will control the change of these values, because as we discussed, we want the lower curves to have a higher amplitude and these curves to have a lower amplitude, right? So the difference between the highest and the lowest numbers should be higher here and very low here. So this domain will control the change of amplitude based on the branch number, right? So it means that this graph mapper will have to generate 109 values, right? So we're taking the range, we're connecting these counts to n, and let's not forget to put x minus 1, so that we are sure that the number of values will be exactly the same as the number of branches we have, right? And then this graph, I will change it to something like this. And then here I want it to change from 1.5, let's say, at the top. Maybe not 1.5, maybe 5 on the top. But we're probably gonna make it even lower in the end, to 15 on the bottom, right? So we really want this amplitude to be quite high at the bottom. Okay, so I think this is just fine, and then we need to start giving the values to these to the curves inside. Sorry, to the points inside the branch, right? So let's just copy this entire thing, right, like this. But these numbers, we can eliminate them because they're going to be defined by the results from this domain, right? And yeah, so the number here is going to be defined by the length of each branch individually, right? So it's going to be connecting from length to number. And here we're going to set this domain to something like, let's say, yeah, let's say it's going to be from, maybe not from 0, maybe from this number multiplied by 0.12, maybe a bit more, I don't know, from this number to this number, right? And actually we have to graph it as well. Yeah, that's fine. This graph, I don't want to make these curves as simple as that. I want it to be a bit more convoluted, so I'm going to go for sign summation. I'm going to develop somehow nice graph for that. Right, something like this would go. And one more thing I would like to show you today actually is I would like this graph to be symmetrical. I would like the resulting curve to be symmetric. Right? Of course, we can just make this half and mirror it later on. It's fine, but just wanted to show you another nice tool how to make it. So in order to make it symmetric, we're gonna copy this. We're gonna provide half of these values, right, and multiply it by 2. So let's make sure that this result is always gonna be even. So let's say we're gonna round the number to factor number of divisions of that curve, right? So we need to make it always even. So we take this number, we round it to the factor of 2, which gives us an even number all the time, right? This component comes from Pufferfish plugin, by the way. And then here, in the n, the number of divisions, we'll have to go for expression and say x minus 1, so that the end number is always going to be the same as the original one, right? So it's like this. Then, here, we have to divide this number into divided by 2, right? So get half of the values. And now, yeah, basically we have all the values here. Now we just need to merge it with the reversed list here. So we are getting the symmetry like that. So let's try to see how will it work. How will it work? Let's connect the polyline component to the points which we are going to move here, right? Let's connect it here and let's see how we change. Yes, this is already something, right? So I'm gonna hide all these curves and let's have a look at how does our geometry look like already. It actually doesn't look bad to me. The only thing I realize is that it's not moved to the front enough, so the shape is it still looks like a texture, not like a form, right? So there are two things we're gonna do. First of all, I really want to change this shape to something more pronounced, right? Something like this. So that now we're getting really high, really tall texture, but then I also want it to be yeah, I want it to be a bit less uh, thick, let's say. I want it to be a bit more, I want the texture to be a bit less pronounced, but at the same time, this entire form to be more pronounced, right? And then now it looks like it's flat. I mean, not flat, but it looks like it's changing only in one direction. I also want it to be a bit more maybe rounded. So in order to achieve this result, we actually have to multiply this graph by another graph. So I'm going to make a relay here, and I'm going to multiply it by some other graph. Let's say I'm going to make a multiplication here. So multiplication. Let's multiply it by this graph. For example, this diagram, right? Something like this. So you see, it looks a lot better. I mean, we can also change this part. We can even make it like that, right? So it gets a bit more, um, or we can make it like this. So we'll see what works best. All right. So I think this looks kind of okay to me. Maybe something like this. Yeah, that's nice. Yeah, and then we can also add more graphs. We can also multiply it by yeah, by other geometries. We can also use some attractors to change the overall look of this shape. But basically, this is, I would say, the essentials of the workflow. And then you can see that we have these polylines. I mean, it's visually it already looks like a form, but let's not forget that these are just curves. So in order to turn it into a real geometry, we need to, not real geometry, real surface or mesh, we need to do this. So we're taking these polylines, we explode them, and then we do all the same things as we did before. So we flip last, we turn it into a simple mesh, right? And then just a few more things that we can do. We can also weld it. So we go to Weaverbird, we find the extract and Weaverbird join meshes and weld. Right, so we're doing something like this. Before we need to flatten it, so yeah, this. Um, yeah, and then we can go for Parametric like subdivision and turn it into something more smooth, right, like this. Or, of course, we can also go for a sub D from mesh. We turn it into something completely smooth, right? Like this. Something to nerves essentially, right? So it's not just smooth. It's also yeah, it's nerves. Right? It's good for diffusions. Okay, so now let's do a few more things. Slowly, I would like to change this graph a little bit to make it a bit more intricate. This is already fine to me, to be honest. But then I wanted to show you one more thing. Basically, yeah, not probably not something that you don't something you know already. I'm just gonna add a gradient to this thing. So we're getting something more like in the preview. Of course, you can also add other gradients if you want. So let's take the bounds. With a, let's say we deconstruct vertices. Okay, this equal there is a base. Then let's say deconstruct the name and take the gradient. So this is the setup for setting up the gradient, and then also construct mesh. So vertices, faces, colors. And then in the end, in order to make it work, we just say custom preview. I mean, in order to make it work in render mode, make it representable in render mode, we just do the custom preview, and for the graph, I'm gonna change it for something a bit more interesting. This. Actually, I kind of like this one, but in the preview I use this one. Pretty straightforward, pretty simple, three color gradient. I'll still go with yeah, let's say this one. And the render mode. Oh, this looks not bad actually. You see, we're getting this geometry highlighted in a nice way. So it's kind of like it. Okay, so this, yeah, one more thing we can also do, we can say blue mesh, like this. It gets a bit more blurred, right? It's a bit more, the transition gets even smoother. And you can also change the shape of this, like the base shape of this geometry. You can change it to something like, uh, yeah, we take the sine summation, for example. You see, we can get a lot more, we can get a lot more intricate shape. We can also go for, we can also change the sun direction how to see how this form looks like, right? So it's also quite an important part, and I know it's mostly for visual effects, but at the same time, you also can uh, see the properties of your form a lot better with this technique. And then you can also go for standard sign and just make something wavy like this. Right? Actually, kind of like this shape. It's quite elegant. And then, of course, by changing any of these sliders, you just make it. And you see, it's a relatively high density mesh, but still the overall geometry moves really quickly, and we can see the changes almost in real time. So it's pretty yeah, it's pretty. And my laptop is quite good, but it's not definitely not the best. But it's still it's good. It's quite productive, right? So you can make the changes of the design and therefore make certain design decisions a lot faster. So I think this is something that is good. Um, yeah, again, changing a couple of variables for the slider and we're getting a different result. I'm still gonna keep this one for the end. So I hope you liked this tutorial. I hope it was quite self-explanatory and not too complicated. Um, as a reminder, yeah, if you have any questions or any suggestions about next tutorials, please don't hesitate to send us direct messages on Instagram and comment on YouTube. We really appreciate and we read all the comments. We try to make tutorials that are interesting for our followers and subscribers. And yeah, also check our parametric design market. And yeah, see you next time.